Welcome. For those of you on time, we're going to show you a short video to get things kicked off and let others join over the next couple of minutes. While the video is running, I'll introduce myself briefly. My name's Ed Martin. I'm the lead product manager for automotive at Unity. This video shows the new Volkswagen Touareg rendered in real time in Unity. I think this video does a great job of showing the power of real time with the ability to switch colors and options, explore the vehicle with complete freedom, and using our new HD render pipeline together with a new stacklet shader to better represent car paint. Call me biased, but I think this is an impressive result for real-time rendering. I know that many of the people on the call today work in other industries other than automotive. Even though a lot of what we'll talk about today uses automotive examples, you're still in the right webinar. Many of the use cases and capabilities we'll talk about today are equally applicable to other industries. Whether you work in design, engineering, marketing, or another discipline, it's likely that you need to create 3D experiences from CAD data. You might need to create high-end visuals such as we just saw in the video clip of the Touareg, or you might need to create VR training apps or even AR apps for a smartphone. Regardless of your use case, you face the same challenge: how to prepare CAD data for real-time 3D. We're here today to share with you how Pixies, together with Unity, can solve this problem. What's more, we're going to share this in the context of a real project, an amazing video that we unveiled at Unite Berlin in June. Just a quick note, I see that a few people are saying that the frame rate on the video is a little low. It's smooth on our end, but due to video compression, you may end up seeing kind of a slower frame rate. Seems like some people are having some issues with FPS, some people aren't, but we're playing a video here. All right. So before we start, I'd like to take a minute to thank the other three people who are presenting in the webinar today, or other two people from presenting the webinar today: Axel Jacquet from Pixies and Adam Myhill from Unity. We're going to cover three things in the webinar today. First, I'll provide a brief introduction. Then Luke and Axel will introduce how Unity and Pixies fit for industrial applications. Finally, Adam will talk about the creative and technical work that went into creating the amazing Lexus video. As we go through these sections, if you have any questions, you can put them in the Q&A tab. We'll answer questions at the end, but we'll be monitoring throughout. And of course, there's the chat channel as well. Before kicking off, though, I'd like to conduct a quick poll to understand your needs better. First, there are really three questions here. We're going to go ahead and launch the poll. How many of you are currently using Unity? What is your current role? And what part of the auto industry or other industry do you work in or with? So we're going to give you about 15, 20 seconds to complete the poll. Give it just a couple of minutes here. We want to compile all your responses. Okay, let's see what kind of results we have. Okay, so great feedback. So it looks like about 2/3 of you are using Unity today, about 1/3 aren't. Most people, really good representation across different roles: design, engineering, training, marketing, services, others, so which is great. And a lot of people from automotive and agencies, but also aerospace, industrial equipment, building products manufacturers, AEC, and others. So really a pretty broad range of participants here, which is really fantastic. So thanks for that. Okay, so I'd like to briefly now talk about why Unity is focused on industry applications, and in particular why we've started with automotive. The answer is that there are four key trends that are transforming the automotive industry in ways that drive a need for Unity. And there are parallels to this in other industries as well. Consumer expectations for convenient digital experiences, mobility as a service, autonomous transportation, and the connected vehicle. Taken together, these four trends are changing the nature of competition. We believe that by solving problems to help automotive customers be more competitive, we can help all of you be more competitive, regardless of your industry. But Despite all the advances we've made in adopting modern PLM tools, in reality, industry is focused on ever more sophisticated ways of capturing, validating, and communicating the product definition. Our tools are still 3D, but at the end of the day, most of the work that goes into developing a new product is focused on aesthetics, performance, reliability, and cost. What we haven't done as well is design consistent and compelling customer experiences, especially when we consider the total experience both inside and outside the vehicle over its life cycle. Here at Unity, we're focused on 5 high-level areas to provide you the tools you need to design a connected customer experience. First, design experience is providing the ability to experience a design in real time throughout the design process. It should be simple for you at any point to pluck design data from PLM and interact with it intuitively. Sales and marketing is about delivering a compelling customer experience throughout all stages of the marketing and sales process. It's more than just a car configurator, though. It's about delivering a persistent, omni-channel way for your customer to interact with your product and service. Training and guidance is providing a way to educate, support, and certify individuals in several different areas, ranging from the people who build cars, the technicians who service them, and even the owners or renters who use them. HMI is a natural fit. Many of you use Unity today for HMI, or human-machine interface, or touchscreens, research and to prototype your HMI, but then when it comes to production, you need to start all over again to re-implement the HMI using highly custom tool chains. We want to make this process simpler. And then finally, simulation and visualization has the potential to address multiple use cases, but our initial focus is the use of Unity for creating realistic virtual worlds with nearly endless scenarios and corner cases, providing you a better way to train and validate autonomous systems. To deliver on this potential, we've introduced an industry bundle, and we'll be expanding this with a new offering we're calling Unity for Industry. The best way to think of Unity for Industry is a collection consisting of Unity Pro, additional features and templates, and of course, Pixie Studio and plugin. In addition, we're offering additional Pixies products such as Pixies Connect and Pixies Review to complement Unity for Industry. One thing you'll see more of in this presentation is amazing visual quality. In addition to the HD render pipeline, or HDRP, which is already in preview, we'll add a set of more than 120 automotive materials to provide better out-of-the-box visuals and make these available to all Unity customers via the Asset Store. If you're interested in beta access, reach out to us in the chat window. One of the main topics we're going to cover today, in addition to the video demonstration from Adam, is importing CAD data and preparing it for real-time 3D. And for that, I'm going to turn it over to Axel from Pixies. But before we hand off, we'd like to launch another poll to understand your challenges of working with 3D data. What is your biggest challenge when using 3D? We'll take about 15, 20 seconds to answer this. Lots and lots of people interested in getting access to the materials, which is great. So just a few more minutes or a few more seconds here for the poll. Let's go ahead and wrap that up. Okay, we'll get the results here. Okay, well, this is convenient. About 3/4 of people have challenges preparing and importing data, which is exactly what Axel's going to be talking about next. Graphics and effects is the next, which Adam is going to be talking about immediately after Axel. And then a few people who need help in knowing how to use Unity. And I would point you to a lot of the resources that we have available. We're also going to be, by the way, launching some new training materials specifically focused on automotive in the very near future. So I think we've got a lot of issues to address all of your main issues. So Axel, please take it away.
Thank you very much, Ed. Hello, everyone. My name is Axel Jacquet. I work at Pixie Software as a product manager for Pixie Studio. So many of you are already using or have tried the powerful CAD-import and data prep tools from Pixies. We've added additional features in the latest release to improve performance and provide even more automation, and expect to see more later this year. So in our demo case today, we are going to show you how to bring an entire car, the beautiful Lexus LC500, into Unity as smoothly as possible. So first, I'll show you the data preparation phase using Pixie Studio before handing over to Ed and Adam for the Unity part. So for that demo, we're going to use Pixie Studio. Pixie Studio is the main Pixie solution when it comes to advanced data preparation. It's the complete toolbox. It embeds all Pixie's optimization algorithms, plus a powerful Python API to create scripts for automation purposes. So let's dive into our Lexus case. In Lexus process, each part of the car corresponds to one CATIA file. In Lexus full database, you find all the unitary parts of the car as one CATIA file, and combined all together, they form what is commonly called a 150% mockup. So, with the right combination of parts, you obtain one vehicle configuration. Now, the rules that say which parts should be included for one specific vehicle configuration are combined in one big Excel sheet that you see there. And it's being used as a rule engine. So basically, by reading this tab, you get all the necessary information to create one vehicle configuration. Anyway, this is one example of how a CAD models database can be managed, but of course, it can be way different from one OEM to another. But simply remember that Pixie provides the tools that offer flexibility to adapt to any process. So now, let's see an example in detail with the steering wheel of the LC500. Here I have a folder containing all the parts to create an assembly of the steering wheel. So I'm simply going to import them all at once in Studio right away. So this is Pixie Studio. I'll just drag and drop all my files here. There. Now let's take a look at the output window here at the left side. Every action is being listed there, and maybe you can see that each CATIA file takes here approximately 1 second to be imported. And that's one key thing about Pixies. We load CAD files very quickly and efficiently. I'm gonna wait a few more seconds so that my assembly is over. Okay. Great. And let's go right away to the left side of the screen here. And what you see here, the product structure window. And here you find all the imported CATIA files. And also, as you can see, we preserved the hierarchy, the exact same one, the one we had in CATIA. So Pixie keeps this kind of information along with all the metadata that can be attached to each node of the hierarchy. Now, I believe you see in the viewer a steering wheel, but what is being displayed here in the viewer are not meshes yet. This is Pixie Studio's representation of original CAD surfaces. And this is a very specific and important thing about CAD models coming from CAD software like CATIA or NX or Inventor. They contain only parametric, mathematically defined surfaces. And the surfaces, well, they need to be translated into meshes that can be handled by a game engine like Unity. And that's precisely what Pixie solutions do. So what we're going to do now is simply transform these parametric surfaces that we see here into optimized meshes. So first, let's do some preparatory work on these surfaces so our tessellation algorithm can perform a good job afterwards. And it's another key feature in Pixies. We know how to deal with CAD models and optimize them in the first place. So from the CAD menu here, I'm going to use a Reaper CAD. I'm going to leave the settings to default and click execute. So I guess you didn't see much there. It's not very spectacular, but basically the algorithm just removed possible gaps between CAD faces or overlapping faces, and it also tried to orient all the faces consistently. Now, another important thing here is that we keep the history of these modifications throughout the whole process. So on the right side of the interface here, you can see the modifier panel here. And you can see that my Reaper CAD has been saved along with its settings. So basically, if I want, I can change one of my settings and click run again. which means we get to change settings afterwards if necessary. Now, let's move on to actually creating a mesh out of the CAD surfaces. So from the CAD menu again, we're going to access one of the most powerful algorithms from Pixies, which is the tessellate algorithm here. So you have a bunch of settings exposed. Some are in the advanced menu here, but the most important one are here. We have the max sag, the max length, and the max angle. I will not explain here too much in details each setting, but you can find more explanation about them in the API documentation, accessible from here if you want. So here you can see that for each setting, you have some information and some pictures to help you understand. And also you can go to the help menu here and API documentation. So anyway, what you should know is that the sag here is also commonly called the chord error. And it basically defines the distance between the original CAD surface and the resulting mesh. So let's set that to 0.1 millimeter. 0.1 is generally a good global setting for a car interior to obtain a good balance between mesh precision and limited polygon count. So let's press execute there. And there, as you can see, we obtain in just a few seconds a beautiful mesh optimized that can be suitable for, well, most use cases. Here I can turn on the wireframe so that you can see that we have a very light mesh with a low density polygons. And you can also see the polygon count here in the top left-hand corner of the viewer. So around 60,000 triangle for the whole steering wheel, which is quite good actually. Now, if I want, once again, I can go to my modifier tab here to modify some settings and rerun the algorithm. Now, let's have a look at the meshes more in detail. I'm going to zoom in here so that you can see that we have some small icons there. And depending on the precision you're looking for your final application, well, you might need to add some more detail for these small parts, because as you can see, they seem a little bit deformed and underdefined, let's say. And how can we do that automatically? How can we select automatically the small parts to apply specific tessellation settings to them? Well, for that, we're going to go to the selection menu here and pick the select small part function. And let's select all parts, let's say under 25 millimeters. And now, as you can see, we've selected all the small icons. And now I can change the tessellation settings for the selected parts only from the modifier window here. So let's set that to 0.05, for example. Click apply again. And now we have better mesh definitions for the small icons. So here I chose a geometrical criterion to select these parts, but I could have used a metadata, like the material, for example. So let's do that now. So thanks to my Excel file I mentioned before, the rule engine, I know that my Lexus logo here in the center will have a chrome as a material, meaning a very shiny material. So that might show that the mesh is maybe not dense enough, as you may see here. So first, I'm going to my material editor here, and I'm going to create a new material here, and I'm going to name it Chrome. And I'll select my part here. And from the properties panel here, for my selected part, I go to the material line, and I'm going to select my newly created material there. And now that it's been selected, well, I can change again my settings to something finer. Let's say 0.05 again. And we have a better defined mesh. So this time, I chose a metadata to apply your targeting optimization. So typically, this specific action, well, they could have been done in script using the Python API to automatize the process. But more on that later. So, okay, so now our meshes look just nice with a nice smoothing. So they look great. But what about the orientation of the faces? Here, my viewer displays double-sided mode, but it will not be the case in Unity. So let's toggle on the one-sided view, also called the backface scaling mode in 3D application. And we can see that some faces are flipped. They are not facing the right direction. For example, my centerpiece here is just upside down. And to see that even more clearly, we have another mode called the back face color here. And this mode shows reverse faces with an elegant flat pink color instead of a transparent look. And actually it does help a lot at targeting these reverse faces. So now, to reorient everything properly, let's use another important algorithm from the mesh menu here. And let's pick the Reaper mesh. And I'm going to my advanced tab here to make sure that my orient is checked. And let's click execute here. All right. So now all the faces are consistently oriented, and also my repair mesh did what is called a repair on the edges to connect them together. And now my whole model looks just fine. And if I want, I can continue optimizing my model with more Pixie features. For example, I can apply UVs by projection. So I can go to my UV menu here and choose my generate UV by projection. And I'm going to let that as default and click execute. So in just a fraction of a second, we applied some UVs. You don't see much there, but I'm going to toggle on my checker button here. And basically what this is doing is showing all the parts that have UVs applied with this checker texture. And if I select my center part here, for example, I can go again to my UV menu here, show the UV viewer, and you can see that we have a beautiful UV layout. Now, let's move on with optimization, and I'm going to perform a hidden removal algorithm. So I'm going to my optimize mesh here, click hidden removal, and I'll select polygons as a level and click execute. Basically, this algorithm removes all polygons not seen from cameras automatically scattered around the steering wheel. And so as you can see, we've lost more than 10,000 triangles here. And this without affecting the quality of the model. It still looks very, very nice. So now my model looks just fine. And to continue, I can deal with the hierarchy too if I want, here in the left side. I'm going to my scene menu here and click rake tree. And that way I can reduce the depth of the hierarchy by placing all the parts under the root node, as you can see here. And it can be very useful before going to Unity to reduce the number of draw calls by making a hierarchy simplified. And now I want to show you just a little bit of scripting here from the scripting editor at the bottom here. I can use that piece of script to rearrange my hierarchy. So for example, these two first lines here, well, they're going to create a new node called steering wheel. And that loop here is going to place all the parts existing in the scene under this newly created steering wheel node. So I'm going to execute that. And as you can see, in just a few seconds, my hierarchy has been rearranged. Well, I could go even further with more algorithms and more complex strategies, but I think it's enough for now. Anyway, a very important point is that everything that I've done interactively until now, I could have done it with scripting using the Python API. Now, let's remind what we wanted to do in the first place. We want to bring a full LC500 vehicle into Unity. So everything that I've done so far is going through a trial and error process to find the good recipe to optimize a sub-assembly of the Lexus. And now that I'm happy with my recipe, well, I could create a global scenario to run on the complete Lexus 150% database. And well, that's exactly what we did. So I'm gonna reset my scene here and go to plugin here, there. The final scenario for this Lexus use case comes as what we call a plugin. A plugin is basically a sum of Python scripts managed by an XML interface. This is what you see there, all right? And this particular plugin is divided in several tabs. In the first one, I get to choose the folder containing all the CAD files, and here I get to choose the rule engine. In the second tab here, I choose settings for the optimization process. So here we expose only the settings interesting to adjust. And finally, in the last tab here, I get to choose where to save the resulting car assembly as a Pixis file, which is our proprietary format, and additionally to exporting the result as an FBX file. Now, to show it in action, well, I'm going to use it on a subassembly. Guess which one? So I'll use my preset here and simply click execute. So just so you know, here I'm using the new Pixis Studio.batch version. And this particular version of Studio includes an additional import-export Python function for batch processing, which is very powerful. And you will see that in just a few seconds, everything that we've done by hand so far is automatically executed. And what we obtain is a steering wheel with optimized meshes, with all parts sorted in the hierarchy according to the rule engine, and with materials applied to all parts. I'll wait a few more seconds so that it's finished. There we go. And as you can see, we have everything in terms of meshes. We have our full hierarchy. And if I select a part, I can go to the properties panel here and see that my materials has been applied. You can check that we have UVs too. So that's perfect. Now, if you run the scenario to create one complete car configuration, it would take approximately 35 minutes to process. So I won't do it there, of course, but I'm going to load the final Pixis file right now. There it is. And this way you can see how fast Pixis Studio can open a 5 million triangles car assembly. It will take a few more seconds. And finally, what we obtain here is one complete assembly of one vehicle configuration. And as you will see in a few seconds, we have the complete assembly. We have all the exterior and also the indoor, the seats. I'm going to hide here the outdoor so that you can see that. Well, we have everything inside the car. And that's great. So finally, one very important thing. Now that my Lexus scenario is set for good, I can use it extensively and scale my data preparation process. Now, each time my rule engine or my CAD database evolve, I simply need to rerun my scenario. Well, now our car is ready to be imported in Unity, to be staged and used for incredible virtual experiences. So now Ed is going to show you what you can do with that car assembly.
All right, thank you very much, Axel. I'm going to share my screen here real quickly. Okay, so I'm going to show you now the new automotive material library, the beta 1.5. It's composed of over 120 high-quality photoplasmable materials. You'll have everything you need to dress up a full car, such as plastic, leather, glass, car paint, you name it. And I'm going to show you right now how easy it is to dress up the car. So I've got the Lexus LC500 here. And what you're going to see is, first of all, I'm going to apply kind of the standard Unity lit shader from HDRP. But I'm going to contrast that with a new shader called StackLit. So first you see the normal lit shader. Then the StackLit shader we're going to apply that. And you're going to see the difference in realism. So all of a sudden, you can just see the way it scatters the light, the way that it has depth that simply isn't visible on in the standard lit shader. I'm going to go ahead and apply some glass. I pre-recorded this video just so we're going to run through that. You can see the glass will get applied to the windshield and the side window. And again, the same level of quality is available for things like leather and fabric. And of course, for the StackLit shader, actually all of these you'll be able to edit and adjust the materials within the inspector window. These are all going to be available for free in the asset store in 2018.3. Now I'm going to turn things over to Adam so he can show you what kind of amazing creative work you can do with all of Unity's tools. Thank you.
Thanks, Ed. This is Adam here. Thanks for joining. And I'm going to pop over and show you something that we made. So I was in a part of a very small team that had the idea, let's make like prototype a car commercial and let's time box it and do it as fast as we can. We did the whole thing in under a week. We actually did all the cinematics and lighting in a few days. And let me show you the video and then we'll talk about how it was done. Okay. Okay, so here we are. So this is Uni 2018, and this was the project. Here's the beautiful car that we got from Axel, and with the shaders on it. And conceptually, we had the idea we start the city and we drive to the forest. So you can see here, here's the asset store, and these are the beautiful environments that we made for a different project. And if I jump to the end here, this is timeline. This is how we sequenced everything. You can see that here's all the assets in the world. So what we did was we put a basic car animation in with this master timeline, and then we put a bunch of different camera shots in. And I'm going to show you really quickly how we did some of the looks with the graphics and the lighting. We use HDRI images for the skybox, and they're really easy to configure. So you can see here I've got the city level, and in the scene settings I've got a slot for HDRI skies. When you put them in, you can see it adjusts the reflections on the car. You know, we've got different times of day, and then we just got these, like most of these are just free online. You can just search for these. There's as many different times of day and moods and things as you can imagine. So we quickly prototyped the lighting with these. We set a reflection map on the car, and then we set the car down the road, animating. Now, something that's really interesting here is, I'm going to just turn this down, is our camera system, Cinemachine in Unity. And this is how we did all of the animated sequences and all the camera work. But I'm going to show you some of its really powerful features because it's got some things which are really interesting, really fast for blocking in sequences. So if you look at this shot here, we've got this dolly shot where the camera goes around. Let me show you how we set that up. So in the world, we have a dolly track, just like on a film set. You can see it. It's this line here. And you can adjust the shape, move things around, and the camera will animate down that path based on an animation curve that you can supply. So you can have it animated at any speed you'd like down there. And this is where it gets interesting. We have something called procedural composition. It's the only 3D engine to have this level of camera control. And what it lets you do is it lets you say where you would like something targeted to be on the screen. So you can see right here, I'm targeting the car's hood logo. And I'm saying that I would like it compositionally here on the screen. See that crosshair? And we animate that. So let me make this window bigger and I'll show you more of what I mean by that. So we've got an animation track that is animating the X and the Y of that position on the screen. So if I go to the start of the shot, I can say I'd like the car to be on the left and maybe a little bit higher. And then when we get to the middle of the screen, the middle when the car's right there, we can say let's have that be more in the middle. And what we're doing now is we're procedurally composing something, but keyframing how it's composed on screen. And the power of this is you can change your mind. The car can go faster, smaller, you can change the car, and you're still going to get this exact same shot. It's one of the ways that we could build this sequence so quickly. And lastly, on this camera, I'm going to show you something that we did called, it was procedural handheld animation. So if you look here, you can see that we have this system here. It's a multi-channel Perlin noise, and we have different handheld emulations. So that camera shake, when I play it, there's no, you can see there's no camera shake there. But if I turn the amplitude up, and I can show you how this works, you can combine these different curves and putting noise per channel, and you can tune these. I've made a few for you to get started, but you can tune them to be however you'd like. Look at this. When I turn this amplitude back up on the noise and set that to 1, we now have some handheld camera motion. And we use that throughout this entire sequence because it really gives you, you know, more life to the shot. You can really see, I can bring some of those shots alive. Okay, let me jump forward. I'm going to go to the end. And I'm going to show you something really powerful with laying this out. So we've got these two shots here, and we can see here, this is a camera clip, and we're composing the car, and then clip, and this is a closer one. So let me show you that in person. So here's the two cameras. Let me make this a little bit bigger. And you can see we cut between the two. Shot, shot. See that cut? And I can grab this camera and just move it back to make this a bit more dramatic. And then let's say move this one a little bit closer. And you can see how fast this is to work for building your shots. Look at this. This is where it gets really interesting. Look what happens when I overlap the clips. See this region here? That blends all the math of the camera positions. And you can see that that blend is blending all the math between those two. And it's not just blending the camera, it's actually blending everything. So if I were to change my post-processing, we've got a full color grading suite per shot. And that's a really important thing to have at your fingertips, the ability to change anything. This is like it's a professional color grading environment that lives on every single camera if you'd like it to. So I'm going to change this bloom, maybe crank the flare up a little bit. And now not only does the camera change, but the post effects change. Look at that. Just to prove it, let's say do something crazy like go. We'll make this shot black and white and blend from color to black and white. It's a super fast way of working. We have this saying, it's like, you know, every department at your fingertips. Because when you're working on this stuff, it's no problem to go change your mind on a shot. And then you can say, you know what would this whole commercial look like if we made the car red? So you make the car red. And you can go back to the very start and look at the whole show with the car red. Once you get used to working this way, it's really hard to go back to offline rendering. And speaking of rendering, I'll show you how we outputted this. So in Unity, in Timeline, you have a thing called the recorder track. And I will just turn that, unmute that, and you've got clips. And you can record different sections. And you can record it however you'd like. So in this one, we want to render it 4K. You can render from different shots. For this particular project, we rendered it all out at 4K, and then we downsampled it to 1080, just to give you a little bit more anti-aliasing and a little better micro contrast. So that's my walkthrough. You can see that with these tools, we're able to prototype a car commercial to, you know, a very high degree of visual quality, and we did it all, you know, under a week in a very small team of people. So thanks for watching this section. I'll hand it back to you, Ed.
All right, thank you very much, Adam. I really appreciate that. So really, there are just a few key takeaways here that I would like you all to know. And I've been, by the way, actively answering a whole lot of questions, but I can't possibly keep up with all the questions. I'm not fast enough. We'll continue to collect some of the Q&A during the webinar. But first of all, we're delivering a pipeline to create interactive real-time content. And I think we've got a fantastic tool, as you've seen here, from what Axel demonstrated and what Adam demonstrated. Unity and Pixies are partnering together to offer tools for both small and large-scale problems. HDRP is changing the future of real-time 3D. I mean, the ability to create this kind of quality with that kind of just simplified pipeline with data prep from starting with CAD data and moving into these kind of incredible images and videos is just phenomenal. So what we showed you, the Pixies solutions and the capabilities in Unity that we demonstrated are available today, and of course the materials libraries and data. And you can contact us at the address that URL that's shown here, unity.com/solutions/auto. There are a number of you who ask questions about how do I get this, or can I get licenses of that? There is a button on that URL that says talk to a Unity expert. If you click that button, put your name in, we will be in contact with you. So what is next? In a little over a month, on Wednesday, September the 26th, we're going to have a webinar together in conjunction with Gravity Sketch and in partnership with Car Design News, focused on the use of an application built on top of Unity that provides some really cool 3D sketching capabilities with NURBS. If you're interested, more information is available at that same solutions page that I provided you previously. And for those of you who are interested, our Unite event in Los Angeles is taking place in 2 months from now, October 23rd through the 25th in LA. And once again, we're going to have an Auto Tech Summit. Some of you may have attended our summit in Berlin back in June. Had a fantastic Auto Tech Summit with over 300 attendees. And we're expecting even more people in LA. So we're really looking forward to seeing many of you there. If you're interested, there's $100 off with the registration code that is shown here on the screen, UWeb18. So look forward to seeing all of you there.